pointless, to say that we can only use these things, but then we have to come up with all these other things. It's not entirely pointless, because in programming, well, not in this class nor the next class, but the class after that, which is cisp300, Assembly Language Programming, there are some processors that are very simplistic, just so they can save cost. Okay, so the processor itself will only need a tiny little bit of silicon, and therefore on one wafer you can have a lot of those, and so those processors are very inexpensive to manufacture. It is possible that a processor can only give you the ability to do a comparison for less than. Then for everything else, you will have to use logic gates and some other instructions to make it happen. Okay, so something like this, which is a brain teaser in this class, can be a practical problem that you have to solve when you write programs in on an architecture that is very, very simple. All right. So the brain teaser is over. We talked about the new homework assignment. So now we can kind of just continue to talk about conditional statements, because we're not quite done yet with that topic. All right. So we talked about logical operators. We talked about conjunction, disjunction, and negation. And we are going back to the example in this case. So we are on section 6 of module 13. Which was originally written in 2009. Okay, so what I'll do next is I'm going to use Notepad or Mousepad to try to figure out the problem. Okay, so instead of giving you two variables, x and y, and you want to store the maximum into z, I'll give you three variables this time. W, x, and y are given to you. They all have specific values. I want to find the maximum of the three and store that in variable z. How would you solve that problem? That's the question. And then before I forget, this is the row sheet of today. And I'll start with here. How would you solve that problem? You can actually solve that problem with just the concept that we have talked about. But then you will have to understand how to nest, conditional statements. How do you make one conditional statement a part of a branch of another conditional statement? So let's not go there just yet. Okay, let's make it a little bit simpler. Okay, so I'll just say that given three variables, w, x, and y, how do we figure out the maximum and store the maximum in z? This is my problem, okay? This is what I want to do. The question is, how do we do this? Well, I'm going to give you the template of the answer, and then we'll try to figure out how to specify the details. The template of the answer looks like this. If blah, 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 okay, and the blah, blah, blah is going to confirm that w is the maximum. So if w is the maximum, we know what to do with it. Z is going to get the value of w. And then we'll say else, but this time it is not just else. This time it's else if da, da, da. Okay? And in that case, we'll confirm that x is the maximum. All right? If x is the maximum, then we should update z to the same value as x. Else, which means, hey, it's not w, it's not x. Since we only have three variables, it has got to be y. All right, we'll update z to have the same value as y, and if. So this is a multi-branch. This is what I call a multi-branch conditional statement, because it's not just two anymore. Now it has three branches. Now when you encounter something like this, you have to remind yourself, how do you read a multi-branch conditional statement like this? And the way you do it is you read it from top to bottom. When you find one condition that is true, you will perform that particular branch, and then you go all the way to the end. Okay. All right. So let's go ahead and try to see what we can put here. Which condition will guarantee that w is in fact the maximum of the three?
If w is greater than x and y.
All right. If w is greater than x and y. Well, we can't, I know what you mean, but we cannot express it this way. The reason why we can express it this way is AND is a Boolean operator, which means the two sides of AND, at least in programming, they have to be true-false values. In this case, x is number, y is a number too. So how do we kind of move things around a little bit to express exactly the same thing?
And W is greater than Y.
Yep. So we separate it into two different comparisons, and then we say, okay, if W is greater than X and W is greater than Y, then Z gets W. Now I wouldn't copy this down, not only because it is all being recorded. Let me just double check before I say that. Yep, it is still recording, and I'm just going to also double check the recording device. It is recording from the right device. So we are good, okay? So I wouldn't spend too much time copying this. But the reason why I do not recommend you to copy this is not only because this is all being recorded, but also because this is not entirely right. Okay, so we'll find out why it's not right. Go ahead.
Are you going to post it?
It is going all the way to YouTube.
Yeah, no. Are you going to post it on YouTube? I look every day. Sometimes.
All right. Yeah, I usually would do it at the end of the day because I have 3 classes today. My last class, I get out of the campus at 10 p.m. tonight. So I'll probably have dinner first before I do.
Tomorrow. It'll be up to like
Yeah, it will be up tomorrow. If I forget, just send me an email so I can go ahead and do it. Yep.
Do you want to use greater or equal for W, just in case there?
I would use greater than or equal to. However, I'm not going to change it so that we can see why this is not going to work. Okay? So that's a good way to do it. All right, what about this one? How do I confirm that X is, in fact, the maximum? Same thing, right? I mean, if I know the other one, this one is really just about the same thing, except we have to make sure that X is greater than the other 2 variables. If X...
Y, not Z.
Oh, that's right. Thank you. All right. So let's just say that this is my algorithm, and we are going to this else if thing here. Okay, so this is the trail map of a multi-branch conditional statement. And what I'll do is I will make my notepad side by side to this picture. All right. So what is happening here is this whole thing is considered as condition 1. This entire thing is considered as condition 2. This action here is this branch here. This action is this branch here. And then this action is this branch here. Because what is happening here is if this condition is true, which means if this condition is true, then we go to this branch, we perform this action, which is actually this action here in pseudocode, and then we get all the way out of the entire conditional statement. Which means condition 2 can be true as well as when condition 1 is true. But if condition 1 is true, I don't even care about condition 2. I don't even evaluate condition 2. Is that okay so far? Now, what if condition 1, which is this one, is false? Well, according to this map here, we have to follow the branch that is labeled false. And then in that case, we have no choice but to evaluate condition 2. Now, based on the result of condition 2, we can either go this way or we can go this way. If condition 2 is true, we go this way. If condition 2 is false, we go this way. But either way, after we perform that branch, we have to get out of the entire conditional statement. Are we doing okay so far? Kind of mapping the pseudocode on the right-hand side to the trail map on the left-hand side. Now, this is really, really important because it means the order of evaluating the conditions becomes important. You always want to evaluate and read from top to bottom. The first one that matches, then when you have one that matches, you have to execute the action associated with that condition, and then after the action, you get out of the conditional statement. Yep.
Can you have an infinite number of conditions? Like just a giant list, like 30 different conditions. Like,
Yep.
does it meet this? Nope. Next one.
Yep, you can keep going down. But in things can get very confusing real fast, and I'll give you guys some really confusing examples later on. Okay, yep.
For general, for structured code, do we generally want to exit an if then statement like that on the left hand side always, so that the first branch is the exit is on the left hand side, and then the second
mean
one
here?
is in the middle.
So like this one?
Yeah, like the first exit statement, the first true statement is on the left, and then the second.
Yeah, well, I just personally I just put the true branch on the left hand side, and the false branch on the right hand side.
The last one.
But there's no convention saying that has to be the way to be done. I mean, this is really nothing more than a graphical representation of the logic.
It's easier to read.
Yeah, I'm usually consistent with that particular standard. Now, there's one other observation that some of you may realize and some of you may not. Go ahead. Hmm? No, you do not, because this is considered one single conditional statement that has multiple branches. Only certain programming languages can do it. C is not one of those. C, okay, translating this concept to C is really tricky because the syntax of C, is really, it doesn't lend itself to be intuitive like what we are seeing here. So I'm just going to give you guys a warning about that because when you try to implement something like this in C, the logic may not perform what you think it should be performing, and yet it is not a syntax error. Okay, so I'll just leave it at that for the time being. All right. So I want to point out another thing. Has anyone observed that this part here looks like a miniature conditional statement? One branch coming in, a condition, branching to the left, branching to the right, depending on the result of the condition, and both branches exit, to a single, exit route. So this thing, it's all by itself, looks like a miniature conditional statement that is a branch of the overall conditional statement. If you have observed that, congratulations, because you have just understood nested statements. Okay. But if you don't, no worry, we'll talk about that later anyway. All right? All right, so let's go ahead and, give us, some test cases so we can see, how well this logic works. Here is my next question that I want you guys to think about a little bit before I give you an answer or before I comment on it, okay? And I'll just go ahead and do the copying first. Oops. Wrong focus. Okay, I forgot to change that setting. I go to Windows Manager, focus. Focus follows mouse. Yep, that's what I want to do. See, now I can just move my mouse without clicking, and the focus follows the mouse, which is a really handy feature. I always enable that feature, but occasionally I kind of forget about it. All right, so we can go ahead and copy the logic here. If W is greater than X, and remember this is actually not entirely correct, so we'll go ahead and test it with certain test cases and see when can we find out that this is actually not entirely correct. Oops, else get rid of the rest. Z gets Y, and if do all the indentation, and if you don't